Welcome to yet another session in managerial economics where we're going to look at how the market demand curve is derived. We use what we call the horizontal summation of individual consumers' demand. So your demand and my demand collectively will make up the market. So we have an individual A and an individual B. This is my demand and this is your demand. At 3 units, at one quarter price, and at 2 units, 1/4 price. When you combine these two, you're going to add the 2 and the 3 to form our market demand for 5 at the same equilibrium market price. So dx for the market is simply adding demand 1 plus demand 2. That is how we derive the market demand equation. So the market demand equation is affected by the factors: 1, which is called the price of the unit; number 2, the population size of the customers in the market; number 3, the income of the consumer, the disposable income, which is the income spent on the commodities; number 4, the price of related goods, mainly the substitute or complementary goods; and number 5, the tests. These are the factors collectively that affect the market demand. So the demand faced by a firm can be elaborated by 4 key market structures. We have a monopoly. This is a market structure where one major seller is involved. This major seller in this market structure has market power in pricing decisions. The individual or the firm is a price setter. A good example is Zesco. This price setter demand is inelastic. Demand is inelastic, meaning people can only complain, but the price will remain the same. The good is unique. The firms have economies of scale. We also have an oligopoly market structure. This is where 2 or 3 firms merge to form a cartel or a collusion. The pricing here is interdependent. They make decisions interdependently. So their demand has a kink shape. It looks like this. This is an oligopolistic market structure. There's heavy price discrimination. The goods here are both differentiated and they are homogeneous, meaning they're the same. We have what we call a monopolistic market structure, where there are several firms that are players in this market structure. The goods are highly differentiated. There is a lot of product differentiation in this market structure, and demand is quite elastic. There is little or no government intervention. The firms here have little price control. We also have what is called the perfectly competitive market, or perfect competition, where you have many buyers and sellers, and the type of good in this market structure is typically the same. We are dealing with markets like an agricultural shop at Sokone market or Soweto market. Here the goods are homogeneous, very identical. Demand is very elastic. People will switch to another good due to what we call substitution effect, because they are well informed as to how much this agricultural product costs. If you decide to charge higher, you'll shift to another product. So we have the following kinds of goods. We have what we call durable goods, we have non-durable goods, we have producer goods, we have complementary substitute goods, We also have public goods and merit goods. And so these types of goods are what form the demand for the market. So we also have what we call a linear demand function, which is expressed in terms of the parameters that were explained: the price of the good, the population size, income, the price of the other good, and the test. This linear equation function produces the types of elasticity. We have a type of elasticity which is called the point elasticity of demand, which is change in quantity over quantity divided by change in price over price, or the change in quantity over change in price times price over quantity. This is what we call our point elasticity of demand. You can simply also find it by getting the gradient of P here, the gradient of Px, which is A1, then you multiply it times the price of X over the annual demand. So A1 times P over Qx. So there's also what we call arc price elasticity. This is simply the elasticity that occurs within a range of prices. It's simply the difference in the quantity over the difference in the price times the summation in the price 1 and 2 over the summation in the quantity. So these ones are the same diagonal, except that here finding the differences and here finding the summations. So how much elasticity do we have from point A to point B? It gives you as a firm the range within which you can navigate to ensure that your prices are either elastic or inelastic. If you're a ShopRite manager and you want to know the point at which people will switch demand, you will try an arc of ranges of prices to say, if I'm going to charge 10 kwacha to 12 kwacha, people will still buy. Above 12 kwacha, I'll lose demand to Pick and Pay. So that arc is simply the range of prices within which you're going to charge to be either elastic, inelastic, or unit. Now, today's topic, we want to look at revenue analysis. But revenue is a little bit or directly related to elasticity. So revenue in terms of elasticity is given by MR is equal to P open brackets 1 plus 1 over elasticity of demand. Some examiners would want to ask you how to derive that function. So TR we know is equal to price times quantity. And we know that MR is equal to DTR okay. So this is our MR. So now we'll be asked to show that MR is equal to price 1 plus 1 over elasticity of demand. So we know that MR is equal to DTR. So we know that DTR is the same as what? Price times quantity. So here we're going to do this price times quantity divided by this is DTR over DQ. the TR over the Q. Okay, so from this point is where I'm going to expand this. But before I go any further, for those that will be understanding calculus for the first time, I'll need to take you briefly in how revenue analysis is attained. So revenue simply talks about incremental changes in the total revenue. So our total revenue, like has been said, is given by price times quantity. Average revenue is given by total revenue over quantity. Marginal revenue is given by the change in the revenue, which is the TR over the TC, the quantity. So you'll be given the price function, for instance, as 1000 minus 100Q. You're asked to find the total revenue, the marginal revenue, and the average revenue, and also to maximize revenue. So maximizing revenue occurs when the marginal revenue is equal to 0. So our total revenue here is simply found by multiplying price times quantity. We're already given our price here as 1000 minus 100Q. Then the Q is never given, you just impute it here. So when you expand that, we're going to have 1000Q minus 100Q squared. This is called our total revenue. To find our marginal revenue, we simply differentiate. By now, I'm sure most of you have attended my classes for differentiation. So how do we differentiate this? Our 1000Q becomes 1000. 100Q squared, the 2 times 100 is 200. Then 1 from there will be 200 what? 200Q. Then to maximize this, our revenue, we know that our marginal revenue must be equal to 0. So we equate this when this 200 goes this side, it will be a positive, to be 200Q. Then when this 1000 goes the other side, it will be a positive. So this one will come this side and the 1000 will remain. So we'll divide both sides by 200. Divide both sides by 200. We're going to get our quantity as what? As 5. Then we substitute the quantity of 5 into the price function to find the price that maximizes revenue. So when you put a 5 there, it will be 1000 minus 500, meaning our price will be 500. So this is how we maximize our revenue function. So price times quantity, our P is here, which is our price, times quantity, we imputed the Q. So this is 1000 times Q is 1000Q. 100Q times Q is 100Q squared. and we differentiate this. By the way, the shortcut for making converting P to marginal revenue is simply multiplying a 2 on the gradient. So it becomes marginal revenue. This will be 1000 minus 200Q. This is the shortcut for making the price a marginal revenue. We just multiply a 2 on the gradient. Here, leave it as it is. Okay, so this is the relationship between marginal revenue and elasticity is as follows. At a point when marginal revenue is increasing, we call that the demand elasticity is positive. At a point where marginal revenue is 0, this is a point where the total revenue is maximum here. So as long as total revenue is increasing, the elasticity of demand is positive. It's greater than 1. It is elastic. Where the total revenue is now going down, at the point where it's turning, the maximum point where total revenue is maximum, elasticity of demand is elastic, unit elastic. As soon as it begins going down, elasticity of demand becomes inelastic. This is the relationship that exists between total revenue, marginal revenue, and elasticity. So elasticity is,
Collins,
yes, please.
could I please take you back to the calculation
Yes, please.
when you maximized profit?
Mm-hmm.
Could you just where you substituted 5?
Here.
Okay, that's what I wanted to see.
So when marginal revenue is equated to 0, the 200 will go the other side, it will be positive. So we divide 200 on both sides. 200 into 1000, we get a 5. So this 5 is just part of maximizing. We need to find both price and quantity that will maximize revenue. So when you put this 5 in here, it will be 500. So 1000 minus 500 is 500. That is on revenue analysis. So maybe to just enhance on what I have just discussed. To begin with, total revenue is equal to price multiplied times quantity. And total revenue is maximized when marginal revenue is equal to 0. These are the key concepts you need to know. When we equate marginal revenue to 0, we are maximizing the total revenue. So now the marginal revenue by definition is simply the change in total revenue divided by the change in the quantity sold. Marginal revenue can be defined as the revenue earned by selling one more extra unit of a commodity. If you're using differentiation of calculus, it is dtr over dq. So we looked at an example where we have our price is equal to 8 minus 2x for good x. For good y, 20 minus 0.5 y. And the cost is given as follows. So we've been asked in this context to find the total revenue, the profit, and the number of units that will maximize good x and good y. So we're going to use our knowledge from what we have just begun. So this is a combination of two products, good x and good y. So let me dominate on just good x first of all. Good x is given by P is equal to 8 minus 2x. So can somebody remind me, how do we find total revenue?
Total revenue is equal to price times quantity.
Price times quantity. So what is our price in this case?
8 minus 2x.
And what is our quantity?
Our quantity is just Q.
Okay. In this case, we're using the letter x, so it is x, right? So our total revenue becomes 8x minus 2x squared. This is our total revenue. What becomes our marginal revenue? Somebody assist. What becomes our marginal revenue?
8 minus 4x.
8 minus 4x. Good. So how do we maximize revenue for good x?
You equate
By
it to
equating
0.
0.
So 0 is equal to 8 minus 4x. So when this one goes this side, 4x is equal to what? 8. So x is equal to what?
2.
That's the quantity. Then how do we find the price? Where
You
there's
slot it.
x, what do we put?
You put 2.
All right. So what becomes our price?
4.
Okay, so this is for good x. We're doing revenue analysis. How many units to maximize good x? 2. At what price? 4. Now I want you to try to do the same. Find the number of units that will maximize good y and at what price. I'll give you 2 minutes. On your books, get ready, go. Calculate the total revenue, the marginal revenue, and give me the units that will maximize and the price that will maximize good x. Any answers?
Y is equal to 20 and the price is 10.
Okay. Any others?
So
Same. Okay. Okay, so let's see. Here we found 4 kwacha and how many units? 2 units. Let's see. Here you find 10 kwacha and how many is 20. That's correct. Now, the other question is find the maximum revenue itself. Find the maximum revenue itself. So if you're asked to find the maximum revenue itself, we know that TR is got what? Price times quantity. TR is equal to price times quantity. So our price is 4, the quantity is 2. So the maximum revenue is 8 itself. Likewise, that's what you would do on the other one. Okay, so we find 8 for good X and 200 for good Y. So the maximum revenue would therefore be 208. That is our maximum revenue. Okay, then you will now be asked to calculate the elasticity of demand. Since I explained the elasticity of demand, I will do the same on good X and you do on good Y. So here we have 2 okay. Whenever P is subject to formula, the formula for elasticity of demand is 1 over negative B times price over quantity. So in this case, our B is a slab here. So we're going to say 1 over negative 2.
Collins, sorry to cut you short. Now, in the prior lecture that we had, we used it's getting a bit fuzzy when you use which kind of formula to calculate elasticity of demand. Remember, in the other lecture, we're using something different.
Okay, I'll go through. I'm using the basic formula. I'll get back to you on that other one. So in this case, we need to use any of the formulas that you can. This is a linear equation. You can use calculus. Those that don't know calculus, you need to know that demand function is written in terms of A minus BQ. This is called an inverse demand function. So if you're using the inverse demand function, the formula is that one on top there. But if you're using a direct demand function, A minus BP, the formula for elasticity is negative B times price over quantity. So our B is negative 2. And since P is subject to the formula, we're using the inverse elasticity formula. The price that maximizes, we found as what? Price that maximizes, we found as 4 kwacha, and the units were 2 units. So here was 4, and here we have 2. So this will be 4 over 4, which is negative 1. Demand here is unit elastic. However, if you're so in love with calculus, you can simply say elasticity of demand is 1 over dp over dq. In this case, we have x times price over good x. So when you differentiate this one, you're going to have dp over dx, which is a derivative of that one, which is -2. So using this, we're going to have 1 over -2. The price of good x was 4 kwacha. That maximizes revenue. And our final answer here we're going to get is still the same. Now, please don't confuse this one to the previous class we had where we had a linear regression which had multivariables. We're just picking the figures. Even here, it's the same thing. We're picking the figures here. But there, you remember that Q was subject of formula. So whenever Q is subject of formula, we pick the numbers as they are. We don't get the inverse. So with the formula that I've just mentioned right now, I want you to find the elasticity that maximizes revenue for good Y. What is the elasticity that maximizes revenue for good Y?
-1.
For -1, the others. Okay, how did you find the figure? And can you lead us through? Our P is got what?
Our P is equal to 10.
10. And our
Yes.
Q is equal to what?
20.
And our function, what was our function?
Our function for elasticity of demand.
No, the demand function. P is equal to what?
P is equal to 20 minus 0.5y.
So how do you find the elasticity of demand? 1 over what? B times price over quantity.
Yes.
What is our B?
Our B is
Negative
0.5.
And our price?
10,
And our quantity?
20,
And what do we get?
-1.
And what is our comment at this point?
Unit elastic.
So, Mr. Tembo, elasticity ranges between 3 key terms. We have 0, we have -1, we have -2. When the answer falls within here, 0 point something, it is inelastic. At exactly 1, it is unit elastic. Above 1, it is elastic. So that is how we comment elasticities in that term. Okay, so we are still doing
Well, before I continue, I think I was behind a bit. How are we finding the B?
how are we
The
finding
elasticity of demand is got 1 over n minus B. How do you find the B?
All right, thank you for that. So Mr. Tembo, if you have a function, for instance, P is equal to 10 minus 3Q, and your price that maximizes revenue here maybe is 10, and your price that maximizes, and the quantity that maximizes revenue, sorry, is 4. And also you're given the same function, maybe you're given 10 minus 4p. According to elasticity, if p is subject to formula, the formula is 1 over b negative times price over quantity. This b is simply the number that comes before the q, the gradient, right? So our b is negative 3. If the subject formula is q, the elasticity formula we're going to use in this case is a direct demand. We just get negative b times price over quantity. So here we're going to put 1 over negative 3 times price, which is what? 10, over quantity, which is what? 4. So here we're going to get 10 over negative 12. Okay, which is negative 0. What? Negative 0.8, is it? Or negative 0.9. So this means demand is inelastic. Here our B is simply the guy that comes before the letter. It is 4. But we're not going to use the inverse formula because this demand is called a direct demand. So here we're simply going to get negative 4 times price, which is what? 10, and our quantity, which is 4. So here we're going to get 40 over 4, which is negative what? Negative 10. Here demand is elastic. Here demand is inelastic. So to answer your question, your B is simply a coefficient of the slope. Is that clear?
Yes, very clear.
All right. So this is how to find elasticity even without using calculus. This is how we find elasticity even without using calculus. So what determines elasticity? How many closed substitutes you have. The more closed substitutes you have, the more people will navigate to another good. The other factor that affects elasticity is how narrowly it is defined, how more available it is to adjust the price changes. This is what affects elasticity. So if you have few substitutes, then elasticity is high. If it's defined broadly, then you have less elasticity of demand. If you have less substitutes, less elasticity of demand. If you have less time to adjust prices, then you have less elasticity. We also have income elasticity of demand. It talks about how people react due to changes in your income. I discovered that most people who come from areas that are high earning, demand of elasticity is inelastic. These guys will package tomatoes in your area, Mr. Tembo, and you buy without asking twice whether this is 5 kwacha or 10 kwacha or 15 kwacha. It is our wives that are very elastic. The time I took my wife or she took me for shopping, next time I opted to just wait for her outside because these women, they know where it's cheapest. When you go with them in the markets, they'll go inside the thickest because they are what? They are very elastic. They think men are so extravagant. We buy from quick shops where prices are 10 times more. So income elasticity looks at how we react to our behaviors to buying things with respect to our income. So For daily usable goods, demand elasticity is high. Now, income elasticity is very important because it defines three types of goods: an inferior good, a normal good, and a luxury good. The formula for elasticity of income, if you're using a linear function which has many variables, simply coefficient I over the annual demand. Or if you're using calculus, it's the Q over the I over I times the quantity. If you get a negative elasticity of income, we know that that is an inferior good. An inferior good is a good whose demand will go down when your income goes up. If you're given by the PF government a grant of youth empowerment of 350, the cars will be driving now, even a Mac X become an inferior good. You'll be wanting to drive in more expensive cars. So an inferior good comes to be the good that you join and want to enjoy more becomes your superior good. When the elasticity of income is between 0 and 1, that's a normal good. When the elasticity of income now exceeds 1, that is a luxurious good. Luxurious goods can be goods like Irish coffee or Irish tea, and some of these things. So income elasticity can also have an arc definition. Like I said, it becomes a normal good if it's more than 0. If it's less than 0, it's an inferior good. Cross price elasticity looks at how we react to our demand when we are looking at the other good. How many will I buy? Ladies, which detergent do you use? Is it Aloha, Mac, Powder, Boom, Bullet? If all of them were at the same price, 20 kwacha, 20 kwacha, same 500 grams, which one would you go for? Ladies, I'm trying to make this as practical as
Maybe maybe Mac because of the brand itself that it has made.
okay, and you would go for Mac. Yoda. Okay, so the key concept here is this. It looks at the behavior that one consumer has for one good whilst looking at the other. So for cross price elasticity, if our elasticity is negative, we call them complementary goods. If the cross price elasticity is positive, it is called a substitute good. Substitute goods are goods with the same usage. Margarine and butter. If margarine goes up, people demand more of butter, holding all things constant. So if your elasticity cross price is negative, just know that those types of goods you're dealing with are what? Complement.
Okay.
If you are dealing with substitute goods and you get your elasticity of demand, which is a positive, then you discover that this is a what? A substitute good. They are substitutes. So there are of course other factors that are related to demand theory, such as international convergence of tastes. We know how certain products are not compatible with our Zambian system. You're buying commodities that have a certain plugging system, so you may not demand it because it may not be compatible. Other things could be growth of electronic commerce. You may not have certain compatibilities of systems with the developing countries compared to the developed countries, and so the demand may be affected by those other factors. So for now, I've tried to labor hard to just combine marginal revenue analysis with elasticity of demand and a few components of other elasticities. So read on estimation and forecasting, where we're going to look at how we're able to forecast using regression, how we're able to use the regression equation to forecast for sales, and also how we're going to use this using what is called the test of significance. So this is our next lecture. For now, we'll end here. Have a good evening.
Thank you.